There's learning about mathematics, and there's doing mathematics. And this program is mostly about doing mathematics. We have here 5 mathematics students, and we're going to invite them to do some mathematics together. What I'm proposing to do is to set you something to investigate. And I will then watch you as you get started. I won't intervene unless you specifically ask me to. Perhaps a little later what I'll do is come back and join you, and I'll probe some details, or we'll see what happens. By the end of the session, what I'm hoping will happen is that we'll see that although we've concentrated on doing mathematics, there are actually some significant lessons for the learning of mathematics.
How can watching 5 other people doing mathematics help you study alone? Try it and see, as you watch, how much of yourself can you recognize in these 5 as they get stuck and unstuck and stuck again on their problem? Actually, they don't have a problem yet. All I did was to ask them to investigate what happens when one coin rolls around a fixed coin.
Right. Let's have some coins.
Eventually, they chose to work on this problem. How many times will the top coin turn about its own center as it rolls around the bottom coin, which is fixed? It goes round once, so 1 is a good guess. But here's once already. In fact, the answer's twice. What happens when the rolling coin is half the size of the fixed coin? It's 3 times. This is the sort of data that our students will be working towards. Let's rejoin them as they begin some experimenting.
Problem now is going to be
holding it.
Well, I'll hold the middle one.
I'll hold this
Right, should we start horizontally?
Yes.
So we can just rotate it right. Where's this going? Yeah,
That's the position of the large one in case it moves.
Remember, they haven't chosen the problem yet. They're trying to discover what problems there might be in these coins.
Right.
That's not very far from an assignment question, trying to understand what the question's about. But there's a danger, one that you might recognize. They've found something to do, plotting some points. So they do it without thinking. They're not trying to ask or answer a question. They're just doing something.
We're going to end up. I'll mark the 2th one there. Yeah. There.
Put it in later.
Yeah, shall I put a mark on the big coin? Into there.
No, then it came. No, it didn't. Didn't it come? Went
No.
over to there.
No,
didn't
that
it?
was large.
No, it came down
And
onto
down to
here.
here.
And then in.
And then we
Then-
went on to blue, didn't we?
Yeah.
So should I change
Into
that?
there.
Blue
Blue
changed
pen.
to blue.
Oh wait a minute, we've got 2 blues.
Yes, that's
we
right. It
went
came
into
down.
there,
and
came
then
back
there.
out.
They're wrapped up in the details of their diagram, but they don't have a question. They should have stopped to ask themselves what they wanted from it. Eventually, it comes.
That's a black dot.
What should we miss?
Oh, I see. It doesn't tell us very much.
Isn't that beautiful?
But what does it tell us?
It took them another 10 minutes to answer that question, but let's skip that. Here they are as the problem begins to emerge.
Yes, but how many times have we been round?
That was 3.
3.
3.
You seem to have got a gap in our...
I wonder if there's any relationship between the number of times we go
Yes,
round
okay,
to the number
from
to the
there.
size,
Round to there.
the difference between the size of one and the other.
I think we ought to try see what we can do mathematically between the circumference of one relating
This one.
to a point rotating
Yes,
around it.
I think
It looks
so.
symmetrical.
Tina and Brian have both identified a problem. The others haven't really heard it yet. It's the same when studying by yourself. There are little voices in your mind that do deserve attention.
Yes, if we go back, because is it going to make any difference if we used the big one? I mean, the paper would be too big. But is it going to be, I mean,
No, you get
presumably
the
it's
same
going to be,
basic shape.
you should get
Yeah.
the same basic shape.
Fine.
yeah.
Yeah. That's just as good.
Yes, I think there must be a relationship between the number of times.
Right, do you
And
want
rental
to
size,
just
yeah.
try it with another coin then? Go and get another pair?
How about if we do two the same size? There's nothing to say it has to be
No.
different
true.
size.
That's true.
Before you,
Get one.
before you do that, would you like to come back and
Yes.
tell me what you've been doing? And
Do you want to take that?
Should we take it in?
yeah, that's a good
Do you want
idea.
it over? Yeah.
I intervened here because I was afraid that more time would be lost, pursuing the diagram yet further. What happens next is the equivalent of stopping yourself briefly while doing any mathematics and asking where you are, what you know, and what you want.
Okay. You've done a diagram. The diagram comes from...
We put that coin in the middle, and we've rotated the smaller coin round to the outside, and we've taken a particular point on the circumference of the smaller circle and marked its path as it rotates around the central coin, and then joined up and got a series of curves. We started there and it's come in like that. Wait a minute.
Start again.
Start
It's
there.
there to there,
Outside, right through.
right the way around to there,
And then blue.
and then the
So we
blue.
went outside and then we sort
That's
of did, we
two
gave up.
revolutions.
That's
Back round the outer one, back in.
back in and back out again.
And we thought at that point we were back on our original
But we
plot,
weren't.
but
Not quite.
we're not.
Wow.
We're a few teeth out.
So you've got a diagram. What does the diagram tell you? What do you want? What is the question you're trying to answer?
Well,
Perhaps you haven't got one yet.
What's
relationship there is between the number of times you go round and the sizes of the coins and the difference between the coins. Is there going to be any difference?
I feel there must be a relationship between the circumference of the coin and the number of revolutions
Yeah.
required to rotate one coin of one particular circumference around a coin of a different circumference.
Does that make sense, Mick?
Yes, as long as we add back to the same starting point at the end.
Yes.
Yes.
Well, this
I
will show
suppose
up
we
in the
could
number of
say to
revolutions
do-
that you have to rotate.
And what? How many do you take for that one? For
There's
this?
three there.
Okay. And somebody just suggested. I think Tina, you suggested two coins the same size.
Yeah.
Yes, I think
See
that
what
might be a
the
good
difference
starting
is.
point.
A good starting point.
Yes.
We've been working for quite a while.
Yes.
All right. Let's have a look at two coins.
Well, what would you do next? There's certainly some more experimenting to be done, but now it has a purpose. They're ready to collect data so they can look for a pattern.
The coin.
Yes. Well, we've got the teeth, so we can. We've got them on the teeth. Well, just to find the relationship between them, maybe a connection between the size of the coins.
That is a
9.
But that's 3. 9.
We count the rotations as well.
That's 1.
That's one.
Small, round, large, around. There's 3
Three
rotations.
rotations.
Large, small.
They're well underway now, and 20 minutes later, they're compiling a table. Let me explain what they've written. On the left is coin size. The first number is the size of the rolling coin. The second, the fixed coin. The middle column is the numbers they'd like to be able to predict, the number of rotations. The third column is an extra, and they'll soon throw it away. So on the bottom line, a coin of size 1, rolling about a coin of size 2, makes 3 turns, as you saw in the animation. But it's not enough just to have a table.
That is saying
Oh, we got that from there.
yes, I know, but
Ah,
you've
yes.
taken 3 is to 1.5. how does that really tie up with this?
That's
What
we
should they
thought.
do
All
now?
we have said is we think they are
The best
related,
response to
that's
Sarah's question
haven't
is to look at the
actually
table
worked
as a whole.
out. Except
Focus on the numbers and ignore the context they come from, the coins and turns and stuff. Here is their table with the extraneous stuff removed. In fact, they took a long time to get anywhere because they got embroiled in the context. But they did add 2 more lines. Can you spot the connection between the pairs of numbers on the left and the numbers on the right? Perhaps not yet, but let's make a change, one that they did as well. To get rid of mixed numbers, like 1.5, rewrite as a fraction. Do this for every number on the right. Now let's focus on the tops of the fractions. Say to yourself what you see there. 1, 1, 2, 2, 1, 3. It's got to be the sum. And it is, in all these special cases. Do the same for the bottoms. It's just the same as the first number. Now let's generalize in symbols. The pair A and B gives the number A plus B divided by A. That's the pattern in the table, the generality. Now you can put back the context. When a coin of radius little r rotates about a fixed coin of radius big R, it turns about its center r plus r divided by little r times. In fact, the students recorded this conjecture as r over little r plus 1. Of course, it hasn't been proved yet.
There is one nasty little point that people like me have a habit of mentioning. Of
Yeah,
course.
all right. Well,
yeah, go on.
Well, I mean, you have a statement which generates a finite amount of data.
Yes.
You give
Yes.
me a finite
Put it
amount of
into-
data, I'll generate data. That's easy.
Yes,
Yes.
so you want to.
But can you convince me that that is what is going on in the coins? So that if I walk up to you with a coin with a ratio of 17 to 386, you'll be able to be sure that the answer is 1 plus. You with me? You see the task?
Where does
Yeah.
all that come from?
Why is that correct?
Oops.
Behind it.
No. So, now that's a little r.
A good, clear diagram, and they're sure about what they know. Big R, radius of the fixed coin. Little r, radius of the rolling coin. This line is fixed and marks the starting position. This one sweeps round from 0 at the start to 2 pi at the end. Now it's at a general position, theta. It's a good diagram because it captures the generality. The rolling coin has rolled some general amount, measured by theta. That's what they know. The group seem fairly confident about that. Are they as sure about what they want?
Call that alpha.
Alpha.
That seemed a little hesitant, and with reason. It's sensible to label alpha, but is it the angle they really want? What do they want? How many times the rolling coin rotates about its center? It was pointing in this direction to start with, so any angle measurement must be referred to this direction. That's the angle they want, but it's not on their diagram. They explored the connection between theta and alpha, and eventually realized that they needed another idea. Notice how, as the idea unfolds, it gets repeated by different people. Saying it for yourself is vital for understanding.
Does that coin travel, in fact, that distance? Does the small coin travel a distance of 2 pi big R plus little r?
Yes.
that how far that coin travels? Is that the distance it travels?
Yes,
Yes, it is.
Of the centre. The centre of
The
it.
centre.
Yeah.
That would be the distance the centre
But
will
that's the
travel.
distance the coin travels, surely, isn't it? If you walk from here to there, then your stomach walks that distance, doesn't it?
Yes. Yeah.
So what you're
But as the coin is travelling that distance, it's rotating.
yes, but the centre doesn't change when you rotate.
No, that's what I'm saying. That
centre
is the
doesn't.
distance that the centre is
Yeah.
actually moving.
That distance is obviously bigger than the circumference there. If we divided that circumference by that circumference, is that significant?
We've got that distance,
Uh-huh.
r plus r,
Yeah.
times 2 pi, divided by that radius.
Yes, the circumference.
By the circumference of the
that
small
one.
circle.
We're sort of back where we started, really, aren't we?
Well, that's what we. But
That's
we've
what
got
we
a
wanted,
Mathematical
wasn't
formula
it?
to prove what we want.
Yes.
What we
Got
wanted.
a formula there,
Mm-hmm.
which purports to come from this diagram,
Mm.
which gives the same answer as your conjecture.
Yes.
Right, yeah.
Mm.
So this is the point to the TMA where you might be tempted to write it down
Mm.
and hope that the tutor doesn't notice there's a little bit of a gap. You can take it as an axiom, there's always a gap, almost always a gap in any argument.
Mm.
But when the gaps are small enough that we don't mind, we accept
Yes.
it. Okay? Now in this particular instance, the gap's just a little bit
Yeah,
wider than I would like.
Yes, I'm not.
Because, Tina, you agree that that gives you this.
Oh, that to that, what I don't get
This is
is
where
that
that came from.
to that.
Good. There's the transition from here to here.
Yes.
I don't understand that.
Now you can, Sarah can say some words at you,
Oh, yeah.
which I will rehearse, which is of the form, the center of the circle, the path of it goes all the way around the outside,
Yes.
so its path is that. Meanwhile, the circle is rotating, and its size is little r, so you divide.
Mm.
Now, Sarah, I don't think Sarah's claiming that that's an explanation. It's just some
No,
words.
Yes.
If you buy it, she'll stop.
Well, I don't understand it. So
Good.
I can't.
Do you want me to just say it again?
I think you
Well,
need to
no,
find
yeah.
some more substance behind it.
Well, if we could take that distance all the way round and put it in a straight line, if we opened it out
Just do it mentally.
Yes.
Yeah.
and said it was a straight line,
Yes.
and then
You've got the wheel, the other one going round and round at the same time.
well, yes, but this one is. Hang on. The distance of around this circle is only 2 pi little r.
Yes.
And if we open that one out,
Yes.
then and we could glue this one onto the outside of the big one,
Yes.
and it would go that many
That
times.
many times. Yes. Yes. So if I had. And we've got circle B, which is the smaller one. The amount of times that B would fit onto A
Is
is A divided by B. Yes. And where A, the length of A is that,
Yes.
and the length of B is that.
Yes.
Right.
So what I ought to do now is to get you to write that down, because one of the biggest difficulties that all students have, and when I say all students, I mean all students of mathematics, research mathematicians are students of mathematics. Everybody has trouble writing down. I'm not sure whether it's going to be appropriate here because of the difficulty of writing, and getting enough paper and so on to write it. There are 3 basic steps here. There's the diagram,
Yes.
Yes.
the statement that the center of the rotating circle moves around the larger circle of circumference 2 pi into r plus little r. The statement that it's rotating and that its circumference is 2 pi little r. The statement that therefore you divide the smaller one into the larger one, and that gives you the number of revolutions, which gives you, in fact, the conjecture. Yeah? When you've written that down, there's still a little wiggly point in there. It's not clear to me, as a totally unbiased observer, it's not clear to me why you're dividing 2 pi little r into 2 pi capital R plus little r. I mean, for a while you were dividing effectively little r into big R. Do you remember with the
Yes.
alpha over theta? And then you discovered you got wrong answers, so you've modified your approach
To get it
slightly, and you
right.
tried to hoodwink me a little bit more. Do you see clearly why you want to divide that in?
I decided to push them,
Can you have a
to try to bridge the gap between what was in their heads and what they were saying.
Okay, now, you now know the total path taken by the little coin. Yeah?
Yes.
So, draw me a path of length 2 pi into capital R plus little r, a straight path. Why not?
This is just 2 pi to r plus little r.
Close bracket. All right, now the center, that's the center of the circle goes along a path of that length.
Yes.
But what is the circle doing at the same time?
Rotating.
It's rotating. Okay, show me a circle rotating as it's going along a path of that length. Draw me a little
Well,
circle at the beginning.
Yes, and it will go, that circle will, that's a bit awkward.
No,
It's
because
going
it's
to go,
C.
yeah.
No, just draw me the circle. Just draw me the circle when it starts.
Oh, there, yeah.
Where's the circle? No,
Well,
that's the
no,
center.
that's the
Right,
center.
Oh,
where's
you want the
circle?
circle, sorry.
Yeah.
No, it isn't. It's C. That's the line.
Well, it doesn't.
Well, that's
it
C.
won't matter
That's
because
the
we can take
point-
a. We
point
can
of
take a.
circumference.
Its center will go
Okay.
along the same
Okay,
distance.
yeah,
All right.
okay.
Cool.
That's better.
Are you all right? Are you all right now?
Yes.
Just rehearse to where we are.
Yes.
This is the coin. This is the rolling coin, and we know that its center goes along a path like that.
Yeah.
Okay. Now, what is the coin doing?
Rotating.
Why is it rotating?
Because it's in contact with the stationary coin.
So put it in contact with something stationary.
Another line.
Okay. Right. Keep it going. It doesn't
Okay.
stop. Okay. Now, the center of the rolling coin rolls how far?
2.
2 pi r plus little r.
And in the process, how many times is that coin rotated, revolved?
2 pi little r, the radius of that. Because
No, no.
That's the circumference of the
that's the
circle.
circumference of that one, yes. That,
Mm,
You said how many times?
oh, how many times it rotates?
well, you've got that.
As that moves across there
As
now,
that
we're going to wrap
point-
this point round.
That point will move, will get to there in one rotation, say.
Yes.
Right?
I'm
That
not
doesn't-
interested in the point, I'm interested in the number of revolutions. the number
Yeah,
of
but that's one
rotations.
revolution, isn't it?
Okay, yes. Good.
And then it will get to, say, there
Mhm.
in another revolution. So you've got to divide that by that. You do?
Do you find the argument convincing?
No, I never accept anything on-
More to the point of this program, have you noticed anything that will help you to learn mathematics? Things like, when in doubt, specialize. But don't get lost doing things just because they're there to be done. There's a purpose in specializing, to detect a generality, a pattern. And bear in mind at all times what you know and what you want. The ultimate task is to bridge that gap.